66 million years ago, in what is now North Dakota, a fish took a breath, and in that single breath, it inhaled the end of the world. That fish is still there. Frozen in stone, mouth open, glass beads from a rock that hit the Yucatan Peninsula still locked inside its gills. And the reason we know exactly what happened to it, down to the minute, is because of one of the most extraordinary fossil sites ever found. A site so perfectly preserved, so forensically detailed, that scientists can reconstruct the sequence of events not just hour by hour, but minute by minute. So that's what this video is about, the 12 minutes that ended 90% of life on Earth. Most people know the asteroid story in broad strokes. Rock hits, dinosaurs die, mammals take over. But what actually happened in those first few minutes is something almost nobody has heard. And the last detail I'm going to share with you, about what the fish bones reveal, is the kind of thing that genuinely stops people mid-sentence when they hear it. So stay with me. The site at the center of all of this is called Tanis. It's a private paleontological site in southwestern North Dakota, part of the heavily studied Hell Creek Formation, a geological region renowned for significant fossil discoveries from the Upper Cretaceous. The team that found it named it after the fictional ancient Egyptian city from Raiders of the Lost Ark, nicknamed Tanis after the real-life ancient Egyptian city referenced in that film, almost as a wink to the site's own mythic status. That name turned out to be more fitting than anyone expected, because what they found inside it reads like something from a movie. In 2019, a team led by Robert De Palma described it as a rare snapshot of the first minutes to hours after the Chicxulub asteroid impact, 66 million years ago. And the detail that changes everything, the detail that separates this site from every other fossil site on Earth, is not a dinosaur bone. The gills are what change the picture. According to the PNAS paper, the spherules in the fish are concentrated in the gill rakers, the bony structures fish use to filter water, rather than scattered through the body. Some of them had tiny glassy beads of impact debris lodged in their gills, which suggests they were still alive and breathing as material thrown up by the asteroid was falling out of the sky. Think about what that means. These fish were breathing the asteroid. The impact happened thousands of miles away, and within minutes, the debris it launched into the atmosphere was already raining down on North Dakota, and these animals were still alive to inhale it. Now here's the thing most people get wrong about this story, and it's the part that makes the 12-minute number real. Everyone assumes the killing wave at Tanis was a tsunami, a giant wall of water that rolled up from the Gulf of Mexico after the impact. Calculations by De Palma's team suggested that such a tsunami would have taken at least 18 hours to travel from the Gulf to Tanis. 18 hours. But the spherules in those fish gills prove the wave arrived almost instantly. So it wasn't a tsunami at all. According to De Palma and colleagues, seismic waves emanating from the asteroid impact reached the Tanis area within minutes. The disturbance sloshed local bodies of water in a phenomenon called a cyche, similar to water flowing back and forth in a bathtub, tossing fish and other organisms around in the wave. Such waves are called cyches. The 2011 Tohoku earthquake near Japan triggered 1.5-meter-tall cyches in Norwegian fjords, 8,000 kilometers away. Now scale that up to the most powerful impact in the last 66 million years, and you start to understand what hit Tanis. Because the earthquake this asteroid generated was not like anything in human memory. The impact triggered earthquakes with magnitudes over 11. For comparison, the most powerful quake on the human record was a 9.5 magnitude in Chile in 1960. The seismic energy was 50,000 times greater than that produced by the devastating 2004 Sumatra earthquake. The ground didn't just shake, it convulsed. And those seismic waves, traveling through the crust of the Earth at enormous speed, arrived at Tanis fast. When De Palma's team did the calculations of the seismic wave propagation from the Chicxulub impact site, they discovered that seismic waves arrived at Tanis within the first half hour after impact. Some estimates put the initial shaking beginning within 9 to 10 minutes. That is inside the 12-minute window. The ground was already moving before the glass rain had even finished falling. And that's the sequence nobody talks about. The asteroid hits the Yucatan. Within roughly 10 minutes, seismic waves reach North Dakota and the river starts sloshing. Tens of minutes after the impact, the Chicxulub agitated large volumes of water and soil in the estuary of the Tanis River. As the Chicxulub proceeded upstream, it swept along bones, teeth, bivalves, ammonites, and plant matter, while impact spherules rained down from the sky. The fish were caught in the middle of all of it, still breathing, still filtering water through their gills, pulling in tiny glass beads that had just been launched from a crater in Mexico and fallen back to Earth at terminal velocity. De Palma's team says the killing is captured in forensic detail in the 1.3-meter-thick Tanis deposit, which it says formed in just a few hours, beginning perhaps 13 minutes after impact. That is the number. Not an estimate, not a dramatization, a calculation based on when the seismic waves could have arrived, cross-referenced against the physical evidence in the rock. 13 minutes, the minimum. And the glass in the gills confirms it. Now I want to tell you about what the glass actually was, because this is the part that sounds impossible. The mud and sand are dotted with glassy spherules, many caught in the gills of the fish, isotopically dated to 65.8 million years ago. They presumably formed from droplets of molten rock launched into the atmosphere at the impact site, which cooled and solidified as they plummeted back to Earth. So the asteroid hits, vaporizes rock, launches that rock into the upper atmosphere as liquid droplets. Those droplets cool into glass beads as they arc through space, and they come back down, not gently, not slowly, at roughly 200 miles per hour as they crater into the mud. These tiny ejected spherules, glassy beads about 1 millimeter wide, were able to travel up to around 3,200 kilometers through the atmosphere because they were so light. The sky over North Dakota that day was not dark with ash. It was raining glass at hurricane speed. And here's what I keep coming back to. The detail that makes this feel less like geology and more like a crime scene. We know what season it happened in. Growth lines examined in the exquisitely preserved bones of fossil fish confirm that all the fish died during the spring growth season. This conclusion was also confirmed by isotopic analysis. Much like their modern counterparts, the ancient sturgeons and paddlefish of the Hell Creek Formation grew in cycles. The carbon isotope ratios in the paddlefish bones match up with this pattern. If these ancient fish lived according to a similar annual cycle as their living relatives, then the signatures in their bones hint that they perished in spring. Scientists read the fish bones like tree rings and landed on a season. Spring. The world ended in spring. That detail hit me differently than I expected it to. Spring is when things are supposed to be starting, not ending. And 66 million years ago, on what might have been a perfectly ordinary spring morning in what is now North Dakota, the sky started raining glass. The site is still giving up new information, by the way. Researchers have described 2 new species of well-preserved sturgeons from the Tanis site in the late Cretaceous Hell Creek Formation of North Dakota. In addition to the 2 newly described sturgeon species, the river was full of paddlefish, bowfish, ammonites, various insects, and aquatic reptiles. And the researchers suspect there are probably many more species lurking in the sediments, waiting to be excavated. The extinction event is simultaneously a discovery event. The same rock layer that marks the end of 90% of species on Earth is also introducing us to species we've never seen before. Now, I want to be straight with you about something, because this is where a lot of coverage of Tanis goes wrong. The fish evidence, the gills, the spherules, the Chicxulub, the season, that's the strong stuff. The fish and the surge deposit that buried them are the strongest published evidence. The more spectacular claims, the ones involving dinosaurs, are less fully described in the peer-reviewed literature. The site has become genuinely controversial in scientific circles. There is no doubt that De Palma's claims have been controversial since they were first presented to the world in 2008. Probably because the announcement was in the New Yorker magazine rather than a peer-reviewed journal, and there have been disputes among researchers about certain data. Investigations concluded there was no intentional fabrication but noted poor research practices. That doesn't undo what the rock itself shows. The glass in the gills is real. The Chicxulub deposit is real. The timing is real. But it's worth knowing that not every headline about Tanis has the same level of evidence behind it. The fish story is extraordinary enough on its own. It doesn't need embellishment. So let's bring this back to where we started. 12 minutes. An asteroid hits the Yucatan Peninsula. Within roughly 10 minutes, the ground in North Dakota is already shaking from a magnitude 11 earthquake. The river starts sloshing. A seiche, not a tsunami, a seiche, surges up the valley and buries everything in its path under more than a meter of sediment. At the same time, glass beads that were molten rock moments ago are falling out of the sky at 200 miles per hour. And the fish are still breathing, still filtering water, still alive, right up until they aren't. We know it happened in spring. We know it happened within minutes. We know because the evidence is still there, locked in stone, in a river valley in North Dakota, named after a movie about a lost ark. And the fish have the glass to prove it. If this kind of deep-time science is your thing, the moments where geology stops being abstract and starts reading like a story, drop a comment below and tell me which part hit hardest. The glass rain, the spring timing, the fish breathing the asteroid. I'm genuinely curious which one lands differently for you. And if you want to keep going, the video on the Paleocene-Eocene thermal maximum is right there. It picks up almost exactly where this one leaves off, when the world that survived this asteroid nearly cooked itself from the inside out. That one is worth your time.